Hello everyone and welcome to another video. Today we'll start topic 3, atoms, elements, and compounds. Let's start by the definition of an atom. The atom is the smallest building unit of an element, and it takes part of chemical reactions and cannot be split into anything smaller. Just to give you a perspective on the size of an atom, you can consider the size of a can of Coke, right? The ratio between the size of that can of Coke to the size of all of Earth is the exact same ratio as a water molecule to the size of the can of Coke, right? And that's a water molecule made of 2 hydrogen atoms and an oxygen atom, alright? So the atom is very, very small. We're going to talk about one of the oldest theories that describe the atom, and that's Bohr's theory. Bohr theorized that the atom is like the solar system, made of a sphere in the middle, surrounded by particles that move around it. Alright? We call that sphere in the middle the nucleus, and the particles that move around it are called electrons. We're talking about the particles that move around the nucleus, right? The nucleus is made of 2 subatomic particles. These are protons and neutrons, right? Protons are positively charged particles with a mass of 1 AMU. If you don't know what AMU is, I will explain it in this documentary chapter. Neutrons have a net charge of 0, right? And they have a mass of 1 AMU. So what does net charge of 0 mean? It means that neutrons carry an amount of positive charge equal to the amount of negative charge. So these two cancel each other and we get a net charge of a neutron of 0, right? So neutrons are charged, yes, but their net charge is equal to 0. Now let's talk about electrons. Electrons are negatively charged particles with a very, very small mass that it's negligible. It's 1/1840, so it's almost non-existing. Alright? From this ratio, you can see that the mass of electrons is very, very small, while the nucleus has protons and neutrons, and both of these have a considerable mass. That's why we say that the mass of an atom is concentrated in the nucleus. We say that the atom is electrically neutral. So what does that mean? It means that the atom in whole doesn't carry an electrical charge, right? Why is that? That's because the number of positively charged protons equals the number of negatively charged electrons. So these two cancel each other and give us a neutral atom, right? Note that we're talking about all of the atom. I'm not just talking about the nucleus or the electrons. No, I'm talking about the whole atom. The whole atom is neutral. The nucleus is positively charged. Why? Because it contains the protons, which carry a positive charge, while the neutrons have a net charge of 0, so we don't count that. So the nucleus is positively charged, the electrons are negatively charged, the whole atom is electrically neutral. Now let's discuss another concept, and that's energy levels, or energy shells, or orbitals. Energy shells are the space around the nucleus where the electrons rotate. Okay, so these are called energy shells or orbitals. The heaviest atom has 7 energy shells. Okay, so these shells are as follows. We have K, L, M, N, and then we have O, P, and Q, right? As we get further from the nucleus, we can notice that the distance between the energy shells get closer together. Right? I hope it's clear in the drawing that K, L, M, and N are on almost an identical distance from each other, while O, P, and Q are closer to each other, right? And the further we get from the nucleus, the higher the electronic energy gets, or the electron energy gets higher. Why is that? Because as we get further from the source of attraction, that's the nucleus is positively charged, attracting the negatively charged electrons. Alright, so as we get further from the source of attraction, we get higher kinetic energy and higher potential energy, right? While when we get closer, for example, K and L in these shells, we are closer to the source of attraction, meaning that we have lower kinetic energy and lower potential energy. So that's the electronic configuration. Energy shells are formed due to the rotation of electrons. So if there are no electrons in an energy shell, that energy shell doesn't exist, right? You can think of that as when you have a fan, right? And that fan has like a brown or a red dot on it, right? And you turn that fan on. When it starts spinning, you get a brown or a red circle due to the movement of that circle. It's just the exact same idea. When electrons spin, the energy shells are formed, right? So hydrogen, for example, has one electron. That one electron is occupying one energy shell. That's K. So how many electrons can be in each of these energy shells? K can carry 2 electrons, L can carry 8, M can carry 18, N can carry 32, 32, and 32, right? We're not getting that far, by the way, in the configuration exams and stuff like that. We're not going that far. I mean, the highest electronic configuration that was mentioned in a test was for calcium 21, right? And we'll talk about that when we discuss the examples. I need you to note something, that the last energy shell cannot carry more than 8 electrons, right? So, for example, energy shell M can carry 18 electrons, but if M is the last energy shell, all it can carry is 8 electrons.